Alrighty, we're back with part B of the grade 9 mathematics sample questions from the 2023 student handbook for the SHSAT. What's up, everybody? It's Greg here. All right, so we're going to jump into question number 2. Maybe I should puff this out a little bit more. So it says the two equations y equals 6x minus 5 and y equals minus 3 plus 7 are represented as lines on a graph. What is the y value of the point of intersection of the two lines? So there's a few ways to meander through this. One way is just to set these two together, because if we know that y is 6x minus 5, y is also minus 3x plus 7. All right, so why don't we just kind of set those equal to each other and live happily ever after? All right, so we have, let me drag this down because I'm going to do alternate solutions to this. So we have 6x minus 5 is equal to minus 3x plus 7. So at this point, all we're going to try to do is solve for x. Okay, I'm going to add 3x to both sides. Okay, that gives me 9x minus 5 equals 7. I'm going to add 5 to both sides. So I get 9x is equal to 12. And at that point, I'm going to divide both sides by 9. So x is equal to 12 over 9. Okay? Or if we simplify that, we can get 4 over 3, dividing both sides by 3, 4/3. All right? So the answer, that's not the answer, where they're asking for what y is. All right? So one thing we can do is just replace that. Since we know what x is now, we can replace it into this equation here. All right? So let's do that. We have 6 times 4/3 minus 5. The 3 goes into the 6 twice, so we get 8 minus 5. 8 minus 5, and that's equal to 3. So therefore, y should equal to 3. So what I'm going to do to double check it is to now feed it into this here as well. So I have minus 3 times 4/3 plus 7. Be careful you're copying things right. I have to be extra careful. I have dyslexia. So anyway, the 3's cancel. I get minus 4 plus 7, and I get 3 again. All right, so my answer for number 2 would be 3. All right, turns out there's another way to solve all this by using simultaneous equations. And again, there's 2 ways to solve even that. Let's see, how can we get some good space here? Let's see, the space for 3. I want space for 3. Let's see, let's do something like that, and I'm going to use the space over here. So we have y is equal to 6x minus 5. And by the way, I think they compacted this here just because it was an extra section, the grade 9 section here. I think if it was in the Form A and Form B proper, they would give a little more space here. I'm not sure why they don't do that for this year, because they do waste space in the formatting and so on. So I don't know what it is. And what I'm going to do anyway is write the second equation right underneath it. Okay. again, there's a whole bunch of ways to do this, but what I want to try to do is metabolize out and get rid of the x's in this case. So one way to do that will be to multiply this whole equation here by 2 every term. So that's going to give me, if I do that, 2y is equal to minus 6x, right, plus 14. Okay, so basically we got rid of this here, right? Now, if I call this equation A and this equation B, if I add them up, I'm going to get y plus 2y is 3y. 6x minus 6x, that goes away. And then I have minus 5 plus 14. So the equal drops down, and that's just equal to 9. And then I have 3y equals 9, divide both sides by 3. And we get y is equal to 3. So that's another way to do this. Again, we can feed the answers back into there and calculate that out. You may have asked if that was true, why don't we just straight up do that? In other words, did we really need to multiply that second equation by 2? Could we not have just subtracted those? All right. So in other words, if we have y is equal to 6x minus 5. Okay, and by the way, we could solve for x here, but we're solving for y. So the goal was to try to get rid of the x's. I could have solved for y here and done a kind of a similar thing. In any event, the second equation was y is equal to minus 3x plus 7. All right, so if I subtract the two of these equations, in other words, if this is equation E and this is equation F, I could subtract them, so y minus y is nothing, right? So we basically get 0 is equal to 6x minus 3x is 9x. And then minus 5 minus 7 is minus 12. Okay, I can add 12 to both sides and get 12 is equal to 9x, right? And then x is going to be equal to the 12 over 9, which is what we got earlier, if you remember over here. Where was it? Right here. So there's a few ways to do this. Some are faster than the others. And if nothing else, this becomes a double check. All right. So one way, we just assign the two equations to each other, solve for x, and then figure out how to solve for y. The other way, we did, especially this first way here, I'll put an arrow towards that. We're doing a simultaneous equation and solving for y in that case. All right. Number 3 is along some of the same lines. Wait, is that right? One of the other ones is. So function y is equal to minus 2x. No, y is equal to positive 2x minus 4 is graphed. The line of the graph travels through point 0, comma, minus 4, and the point 12, comma, y. So if you will, these are two xy pairs. And they're giving us both of the x's, but they're not giving us this y. So what is the value of y in the second point? All right. One way to do that is just run the slope on this. So we get the delta y over delta x, right? So what do we do when we compare those 2 points to try to compute the slope using that? We know the slope is 2, by the way, because of the 2x minus 4, and we're going to use that to our advantage. So basically, we're going to get y minus the minus 4 over 12 minus 0. So that's going to give us y plus 4 over 12. Now, again, we know that the slope is 2, so let's just try to solve for y by making that equal to 2. All right, so at that point, we multiply both sides by 12, and we get y plus 4 is equal to 24. Subtract 4 from both sides. That goes away. Subtract 4 from here, and we get 20. All right. By the way, we can check that because if we pass 20, if we make this 20, we have 20 equals 2x minus 4. If we add 4 to both sides, we get 24 equals 2x. And if we divide both sides by 2, we get x equals 12. And that's what we started with. That's what they gave us, 12 comma y. All right. So that's the deal there. So we're using the slope from the equation I gave us, and we're also computing the slope to figure that out as well. All right. Let me see here. On that note, we could have. Let me change the color of here. They're asking us what y was in the scenario that x is 12. So what we could have done was immediately done 2 times 12, which is 24, minus 4. And so we have 2 ways to solve this now. Obviously, that second way is a zillion times faster. All right, so that's how to solve number 3 in 2 different ways. Let's see, what's the next question we can solve here? Uh, 2, 3, 4, 5, 6, 7, 8. Let me see here. 8's busy. What do we have on the next page? 9, 10, 11, 12. There's not really a more superior one to do first here. Let's do the transformation one and see how much time we end up using here, and how far are we along here? We're into almost 15 minutes. All right. Okay, so we have uh, a shaded triangle on the right and a lighter shaded triangle on the left. The one on the right is JKL, and the one on the left is J prime prime. If you notice, there's a double tick there. There's prime prime, L prime prime, K prime prime. All right, and we're not sure, so we're probably going to end up doing a transformation. It tells us that JKL and JKL double prime are congruent triangles. So that is literally the same triangle, just twisted around in various ways. Okay. Um, and the question is, which 2 transformations were used to make JKL into JKL double prime? All right, so this get ugly fast. Let me try to make this as big as I can without cutting off the answers. And by the way, there's no coordinates given, so we're just basically getting which one is going to end up being the closest to this. In other words, we don't literally know the coordinates of JKL or JLKL double prime either. So A says a transformation happens to the right. So they're taking the darker shaded triangle, moving it to the right in some manner, and then reflecting it across the y-axis. So first of all, let's just try to maybe get a visual of this. So if I just drew a dotted line here, I'm drawing that so it's parallel to the y-axis. If I was to reflect this image here, I would end up with something like that. Okay, and let me just shade it in a blue. All right. So what they're saying for A is that this is going to move that way first. So if I reflected it not on my dotted line, but on Y, I'm going to have that blue shape uh, over here like this. All right. So it's not obviously not A then, because then that lighter shaded shape would look like that one then. So A is out the window. It's not the original thing moved to the right and reflected over the Y. Otherwise, it would look like the empty blue triangle I drew there. And I'll fill it in. All right. So A is not the choice. B, a reflection across the x-axis. So if this is reflected across the x-axis, it would be down here somewhere. All right. That's the first step. And then a clockwise rotation of 270. All right. So let me so first of all, it'd be down here, and it doesn't matter what else we do with it. So it's not down here, it's over there. All right. So no matter what the rotation or the reflection actually looks like, it's not going to be B because it's not in that quadrant. So B is out the window. Okay. C says it's a rotation of 180 degrees about the origin, and then a translation across the x-axis. Man, that's heavy. All right. So this one gets hard to visualize. Uh, what what I don't like about this is a translation across the x-axis. That should have been, if it was true even. So basically, if it's rotated 180 degrees, and I'm just going to write 180 here, it would end up over here. And then if it was reflected upon the x-axis, it would end up back there, okay? But it would have to say rotation, right? It could be moved to the over here, this 180 place, and then rotated in place, or translated in place, or dilated. So just saying it's translated across the x-axis, that's unhelpful. It's not specific. It's too vague. So for that reason, C is out the window as well. So all we're left with now is choice number D. So it says a reflection across the y-axis, okay, and then a counterclockwise rotation of 90 degrees about its center. All right, so let's try to visualize that. So what I'm going to do is so D says D gives us basically it's a reflection across the y-axis. So I did the dotted blue thing, and that was the dotted blue thing was a reflection across this dotted blue line right here. Okay, this dotted blue line right here. Yeah, wait a second. Why is that not working? So if it's reflected across the y, then it's going to end up over here. All right. So it seems the first half of D is correct. That blue shaded thing I put on top of the light shaded triangle, that's where it's supposed to be. All right. Um, and if that's true, just to be clear, this would be J. In fact, I'm going to call it J prime. This over here would be K prime. And this point right here, again, I drew it maybe too sloppy. This would be L prime. All right. So the first part of D, a reflection across the y-axis, it seems correct. And then it says a counterclockwise rotation of 90 degrees about its center. Its is the triangle center. That's not the origin. That's not 0, 0. So the center of the triangle, and let me just make it red just to, and this is not exact. I'm just doing this by eyeball. The center of the triangle might be right there. So if it's rotated counterclockwise, that means this point is going to go this direction. K is going to go this direction. And L is going to go that direction. Well, if it's 90 degrees, and let's throw another color into here. Let's do purple. We added it in before. If I was to Can I get that working right? Probably. If I was to shift that whole thing 90 degrees, look at that. It actually does line up on the lightly colored thing there. So the answer is unequivocally D here. Okay. All right. This one's a tough question because you just can't go by, like I underlined the D reflection across the y-axis. We have to do both steps that they give us in every answer. For instance, like the one that brought us into this quadrant here, this looks like, oh, it can't be the answer. But if the second one moved it over into the right place, then that's fine. So you have to do both steps, even if the first step seems unobvious. All right. All right. So that's the deal with that. That's number 7. Number 8 is also kind of a busy one. So it says the scatter plot shows a set of data, and we can look at it. There's an X, there's a Y. Everything's in units of ones, so there's nothing controversial here. Uh, the scatter plot shows a set of data. Which equation represents the most accurate line of best fit for the data shown in the scatter plot? Okay. So what I'm going to kind of do is just mock up something, because it seems if we start from 0, 0, and I'll just do this free form for right now, the line of best fit uh, seems to be right there. All right. And that actually is y equals x. All right. So that seems to be our answer. But let's just try to look at some of the other scenarios. So y is equal to minus x would be the flip of that. So let's write in here. This is y is equal to x. And we can check it. If I'm at 8, right, then I should get this 8 over here when they match up right there. All right. So y is equal to minus x. And I'm going to change that to red. And we're just sanity checking things here at this point. This is y is equal to minus x. Okay, so the red, that's the red. So it's definitely not that. Okay. G is y is equal to minus x plus 2. All right. So that means it's the same, but it's 2 higher. So let me get a color similar to red. I'll do fuchsia. And it means that it's going to hit right here. So we need to basically go what? One higher? So this is y is equal to minus x plus 2. All right. And then h is y is equal to x plus 2. So we originally started out with purple, and let's try to do something that matches that. There's not really a good choice, so I'm just going to use brown. That's also going to go through that 2 there. So we're going to end up with something like this, I think. Yeah. And that's y is equal to x plus 2. Now, there's no reason that we need to spend the time to label all these. I'm just expounding further as I normally do, just to make sure you guys are realizing what each line means here. Okay. Um, and by the way, as kind of a side note, the line of best fit normally has equal number of points on both sides. And if we just go through some of those, we have point number 1 here, point number 2 there, point number 3 here, point number 4 there, point number 5 there. And on the flip side of that, this would be 1, 2, 3, 4, 5. So they do both have an equal number of points. It's not an absolute requirement per se, because we're just eyeballing this. But that's pretty much the deal there. All right, so that was number 8. All right, let me just make sure I know what I did here. Let's see, that's the answer key. Hey, let's see, 1, 2, 3, 4 we did, 5 we did, 6 we did, 7 and 8 we did, 9 and 10 we still need to do, 11, 12, and 13. So it's 9 and 10 we still need to do. Let's see, how long is this video been going for? We're at 26 minutes, so I am actually going to end this video and put number 9 and 10 into a video by themselves. All right, please like, please subscribe, please share, please comment, please turn on notifications, and send me tons of money. Yeah, all right, peace out.